Okay, so everybody, looking at this, the first thing we need to do is set it equal to 0, correct? So I would not bring this 2x to the fourth over because then this would be negative. I like to keep that positive. So I would subtract 9x squared. And I think most of you were able to think of that. So I would subtract, why isn't this writing? Come on pen. Subtract 9x squared and then add 4. And I'm going to do that all in one step. Is that okay with everybody? Does that confuse anybody? So over here we have 2x to the fourth minus 9x squared plus 4 equals, and those add up to be 0, equals 0. Okay, so we have a fourth, 2, and then a constant. So then I was seeing that most of you were able to remember that's quadratic in form. So we say let x squared equal u. So then wherever there's an x squared, we plug in u. So we have 2u squared minus 9u plus 4 equals 0. Then it's quadratic. I was really glad to see that nobody was quick factoring this. So we have to do what multiplies to be 8 times c, what multiplies to be 8 and adds up to be negative 9. 1 times 8, right? Both negatives. And then we drop our end terms down. So we have 2u squared. We have positive 4. We break down our middle term. So it doesn't matter which one goes first, right? Minus u minus 8u. Is everybody good following up to here? Group the first two terms, group the second two terms. The greatest thing in common here is a u, and then left is 2u minus 1. Very good. What's in common here? Negative 4. Then left is u minus 1. Very good. We are good. Factor out 2u minus 1. And then left is u minus 4. Now that was just factoring it. Now we can solve them by setting each of those equal to 0. So we're going to have 2u minus 1 equals 0. We have u minus 4 equals 0. And then we add 1 divided by 2. U is equal to 1/2. Add 4. U is equal to 4. Then we know that x squared is equal to u. So x squared is equal to 1/2. And x squared is equal to 4. Square root it. And then we have x is equal to plus and minus. Now, can't we split this up? Yeah, right? We can, right? So don't we have the square root of 1 over the square root of 2? Which is 1/2. 1 square roots of 2, sorry. Right, everybody? Square root of 1. And then we square root this side, so we get x is equal to plus and minus 2. Now, we have these solutions for right now. Now, this is a really hard problem just because it takes so much to think about. Because now, shouldn't we be rationalizing the denominator? If there's a radical in the bottom, right? So a lot of you got clear to here, and that was great, and I probably even would have given you full points. But if this was an honors class, and really you guys are just as smart as the honors kids, we would rationalize, right? You get why, right? Does everybody get why, or do I need to explain? We can't have a root in the bottom, right? So what would we do? Multiply by the square root of 2 over the square root of 2. So on top, 1 times the square root of 2 is the square root of 2. On bottom, don't we have the square root of 4? 2 times 2, which is 2. So we have x is equal to plus and minus square root of 2 over 2, and x is equal to plus and minus 2. That's 4 solutions as degree 4. Okay, everybody, that was a really, really advanced one. So if you were able to get clear up to here, that's awesome. That was a hard one. Good job. Okay, any questions on that? Okay, I just want to spend a second and review a couple things from the unit. I'm going to make it a goal to review a couple things with you each time so that when we get to the test, you're like, I've seen this so many times that I know it, even though it's been a month. Okay? So remember, state the end behavior informally and formally. What is end behavior? It's what's happening to the far left and far right of the graph, correct? So everybody write it down on your whiteboard, figure out in your groups the answer to this one. Go. So you guys are getting it. Check your answers. So you guys tell me what you get for this one. Up and up, so it was even, it was positive, so we knew it was up and up. I always, to do out the end behavior, draw a quick little picture. So as x is approaching positive infinity, f of x is approaching positive infinity. As x is approaching negative infinity, our function is approaching. Isn't it approaching positive infinity still? Okay, awesome. This one is odd and it's negative. So it has opposite end behavior and it's negative, so it's like a negative line. So we said up and down. I saw most of you say that. I have a quick picture, then I say as x is approaching positive infinity, f of x is approaching negative infinity, right guys? And as x is approaching negative infinity, our function is going upwards to positive infinity. Hey, awesome job. Any questions? Okay, so I don't want us to take time to do this one, but just tell me how you would do it. If I gave you an XY chart and said, find the degree of the polynomial, do you remember how we did this? Yeah, we're taking our y values and subtracting them. Very good, way to remember that. And the one rule is that you subtract this from this, correct? This from this, this from this, this from this. And then when you do it, you got to do that same rule, correct? I'm so glad you said that. You remembered the one rule. You have to remember to check to see if all your x values are changing by the same amount. Way to remember that. You're absolutely correct. So these ones we would be able to do this with. That would be a smart thing to check first. Okay, awesome. So now let's say we took differences the first time and they weren't the same. Then it isn't linear. We take differences again. And then if they weren't the same, we'd say it's not quadratic. And if we took differences again and they were the same, then we call it a cubic. Correct, everybody? I just don't want us to take time to do that because I want to make sure we have plenty of time for the lesson. I do, however, want you to do this one on your whiteboard. So it says, given these zeros, so given these solutions, what is the polynomial? So you're going to have to ask yourself, what does x equals negative 3 with a multiplicity of 2 mean? Ready, set, go. Write me out the polynomial. Okay, let's talk about it. So, we have x is equal to 0 as a solution. We have x is equal to negative 3, and then you would need to write x is equal to negative 3 again. Because it had a multiplicity of 2, doesn't that mean it just happened twice? Now, if we want to find the polynomial, we work backwards and get them equal to 0. This one's already equal to 0. We would add 3. So we have an x plus 3 equals 0. We would add 3. So we have another x plus 3, guys. And then we have this original x. Now, if you're ever multiplying three things together, you multiply 2 together, combine like terms, then multiply in the third one. You could have done these 2 and then multiplied in. So I'm going to do these 2 just because I want to. So x times x is x squared. X times positive 3 is positive 3x. 3x times 3 times x is 3x. And then 3 times 3 is 9. We combine like terms. So we have x squared plus 6x plus 9. Then we would multiply in this x. So that's x cubed plus 6x squared plus 9x, right? We're just going backwards. Is everybody feeling good about that one? Okay, awesome. Now, if I said to you, find the zeros of this and then state the multiplicities of multiple roots. I saw a lot of you not do this one on the homework, and they're the easiest ones. Finding the zeros, isn't that solving it? Don't we want to factor it? Isn't this an already factored form, everybody? Yeah, so this one's an easy one. We would get x, wouldn't we just set all of our factors equal to 0 and solve? So we get x is equal to 0. We have x is equal to 2 with a multiplicity of, that means it happened 3 times, right? And then we get x is equal to negative 1, and we get x is equal to 2 with a multiplicity of, okay. So if I said to you, what's the end behavior? Wouldn't you multiply out our x's? I mean, we wouldn't want to multiply this out. That would take us all day long, right, everybody? But we only need the leading term for end behavior. So we have x to the first, x to the third, x to the first, and x to the fourth. 4, 5, 6, 7, 8, right? That was for that. 9, wouldn't that be degree 9? Positive x to the 9th, so we would have opposite end behavior down and up. Did everybody see how I did that? Okay, awesome. Okay, so we're not going to actually go through and take the time to solve these, but I just want to review with you, because what I told you was true. Pretty much this whole unit is solving polynomials, and we're just learning different methods. So if I said to you, and on the test, there's just the whole back page, there's just going to say, find the real and imaginary solutions, go. So you'll have to look at all of them and decide, how do I find that? So everyone's going to be a different way. So with this one, how many solutions will there be? 2, isn't it quadratic? Wouldn't we solve by factoring if possible? Okay, this one does factor, so we'd solve by factoring. Then we'd be done. If we had something like this, how would you start it? Right, isn't that always our first step, you guys? Factor out the greatest common factor. Are we all paying attention? Because I'm going over this to help you so that in 2 weeks when we test, you're not going to be like, I don't remember that. Guys, we solve these by factoring out the greatest common factor. So we factor out x, left is x squared minus x minus 2. Now don't we have a linear and a quadratic? Now we would solve this one by setting it equal to 0. We'd solve this one by factoring again or quadratic formula, correct? Hey, what about something like this? What would we do? There's 2 different ways. You could factor out the greatest common factor, and then you would factor by grouping, correct? Because if you factor out an x, you'd still have 4 terms. That's absolutely true. We could factor out an x first, and then we'd look inside, and then there'd be 4 terms. We'd have to factor that by grouping. Or we could just factor by grouping right here. Does that make sense, everybody? And then once we factor it, we have to set our factors equal to 0. Let's go through how would we solve this one? Would we just add 8, cube root it? No, right? That's what we learned last time, was like the most missed problem on the test, right? How many solutions should we have? 3? So we know that if we do that, we've only found 1 solution and we're in trouble. Don't we have to factor it using our little trick? This is the difference of 2 cubes. Let's factor it and we won't solve it. So what would my front thing be? Guys, we learned this last time. What would the back thing be? 2, right? We just cube root the front, cube root the back. Then we're going to put in our parentheses, x and 2. Then we're going to do the front with the front, x times x is x squared. The front with the back, isn't that 2x? Back with the back is 4. Then this sign is the same as this sign. This sign's always opposite of that sign, and this sign's always positive. Look, we have the same goal that we had up here. We have a linear and a quadratic. We'd solve this one by setting it equal to 0. This one's going to take quadratic formula. Are we good? I'm feeling a little concerned. Okay, looking at this one, we would solve it by quadratic in form, right? Everybody, u squared and whatnot. So we're good with everything that we've learned so far in the whole unit. Okay, awesome. Let's get to what we're doing today. So today we're doing hold on, I gotta erase this. I wrote something weird first hour on accident. So we're gonna be dividing polynomials, and we're gonna learn 2 different methods today. So today is going to feel like a total change of gears, and it is. And today we're not going to apply it. We're going to learn how to divide polynomials using long division and synthetic division. And then I'll explain why it makes sense and how it's going to help us in the future later. So today we're just learning how to do it, and then we'll actually use it and apply it in the next lesson. Does that sound like a deal, everybody? Okay, so this is going to help us solve polynomials later down the road in this unit, but we just got to first learn how to do that today, dividing polynomials. It's actually not necessarily super hard. It's not hard math at all. It's super easy math, but it's just knowing how to do it. So I'll teach you the process. So first of all, a couple things. If this makes sense to you, the dividing of polynomials is going to make more sense. So everybody look up here for a second. Don't be writing, nothing. Pay attention to this part. I'm starting out really basic here. Not polynomials, but just looking at division in general. 27 divided by 9. We're taking 27 divided by 9. Isn't that 3? Yeah. So didn't 9 divide evenly? Yeah, it came out 3 with no remainder. So if that's true, if 27 divided by 9 is 3 and there was no remainder, then it's true to say that 9 times 3 equals 27, correct? So 9 and 3 were factors of 27. Remember, factors mean what multiply to be, that number or that thing. Does everybody understand? Okay, now let's look at something where it doesn't come out evenly. So looking at this, 9 divided by 2, that's like 4 point something, correct? So it doesn't come out evenly. It doesn't divide evenly, but can't we still divide it? Yes. So we have a remainder of 1. Here's why. 9 divided by 2. How many times does 2 go into it evenly? 4 times, correct? 2, 4, 6, 8. How many is remaining to get to 9? 1. So do you see how I got a remainder of 1, everybody? Okay, so then if that's true, if there's a remainder of 1, then 2 was not a factor of 9, correct? Meaning 2 times nothing multiplies to be 9. So if that's true, then 2 times 4 plus 1 equals 9, right? 2 times 4 is 8, plus the remainder equals 9. Does everybody see how that works? Okay, awesome. So what we're going to do is I'm going to teach you how to do long division of a polynomial. So we're doing number 1 on your worksheet. You're going to need paper. This takes a lot of work. So does everybody have paper out ready to go? And I'm going to put that in there. Yeah, so this was supposed to be 9 as a factor of 27. Does that make sense? Because 9 went into it evenly. Okay. Yeah, I hadn't fixed that from last hour. Okay, so you're just going to have to trust me with this. Long division is just a process. It's not going to make sense of why we're doing what. It's just learning how to do it. And you're just going to have to go with the process, okay? So is everybody comfortable with understanding what I'm saying? It's going to just be like, oh, learn how to do it and then practice it. So this is what we do. We're taking this polynomial and we're dividing it by this polynomial. And yes, today you're not going to apply why we're learning this, but we will a different lesson. So what you're going to do is we're going to take and we're going to put the x plus 3 on the outside of our house. Now we're going to draw in a little house. And if you remember back to grade school, you did division using the same type of house with just numbers. Underneath our house is going to be this. What we were taking and dividing this by. So x squared minus 13x minus 48. So does everybody just see how to set up the division problem? 90% of you will have one of these on your ACT exam where you have to do long division of a polynomial. So you'll want to remember this because if you get that one problem right, you guys, that brings your whole ACT math score up by just 1 point, which is huge. That's the difference between a scholarship and not. Even just 1 point could make a difference. So here we go. This is what we're doing, okay? When dividing by long division, you only focus on the leading terms. So we're taking this polynomial and dividing it by this. We're only going to focus on the leading terms. So I go off to the side. I'm going to make a little bulletin point to show my work. So I'm taking this leading term x squared, and I'm dividing by this leading term x. We're going to ignore everything else for just a second. Does everybody see what I did? We're dividing the leading terms. So what do we get? X. That is what goes on top of the house. So that is going to be part of our answer. Now I call this the circle because we're going to be working in a circle. We went over here, we did a bulletin point, we got x. Now we're up here. And now what we're going to do is take that x or whatever that is and multiply it back down here to both of these. So x times x is what? X squared. You're going to line it up with your other x squared. Does everybody see what I did? Now we're taking x times positive 3, which is positive 3x, correct? Okay, now here is the most important rule. What we're trying to do is we're trying to get x squareds to cancel out. So we need to change the sign on this x squared. However, you can't just take a little piece and change the sign. It's okay to do something to a polynomial as long as you do it to the whole thing. So we're going to multiply -1 to this entire polynomial. So we're going to change the sign on both of these. Does everybody understand? Just change the sign. Now I'm going to draw a line because now we're going to add straight down. We're just combining like terms from here. So x squared minus x squared is 0, correct? Those better divide out, cancel out. So then careful here, -13x minus 3x. Minus 6x, correct? And then we have minus 48, no other like terms. Minus 16x, correct? And then right here we have -48 and nothing to combine with it, so we add it straight down, and that's just -48. Is everybody comfortable up to here? And now we're back to our first step. You go off to the side and start all over. You're going to look at the leading term, focus on the leading term. So now we're looking at, just like when we started here, -16x, that leading term, divided by this leading term, x. What do we get? -16, correct? That's what's in our answer back up top. So we have x minus 16. Now we're just doing this roundabout circle, so the process is the same again. -16 times positive x. -16x. -16 times positive 3 is -48. Now this is the most important and missed step. You have to change the sign on both of those. Change the sign, change the sign. Now you're going to add straight down to see what's left over. Don't those add up to be 0? And those also add up to be 0. So we're done. Like, we get zeros. So this divided evenly. There was no remainder. Does everybody understand? There's no remaining. There was no remainder. So x minus 16 was our answer when we took this polynomial and divided this polynomial. We got x minus 16. Does everybody understand? That is our answer. Yes, of the second. Yes, of both. Yep. Now understand, everybody, this is what's important. Because if you can do that, that's great. But if you can't understand why this is important, then it's going to not make sense. Here's the thing, guys. Since that was a remainder of 0, wasn't this a perfect factor? Didn't that divide perfectly? So this times this equals this, correct? Just like in number division. Does everybody understand that? Okay, perfect. Let's do another one. It just takes practice. It's just a long process. You just have to learn how to do it, and it just takes practice. So let's do another one. Here we go. Number 4. So we set up x plus 2 on the outside of our house because that's what we're going to be dividing by is this x plus 2. This goes underneath the house. 3x cubed minus x squared minus 7x plus 6. Now, I didn't say this, but I'm going to say it now. Long division always works. You can always divide by long division no matter what to any polynomial. So long division always works no matter what. So we go off to the side. We make our bulletin point. We focus on the leading terms. So we're taking this polynomial divided by this. So we have 3x cubed divided by x. What do we get? 3x squared. That's what goes on top. I'm going to line it up with my x squared just to keep my work nice and pretty. So we have 3x squared. Is everybody good up to there? Now we take and multiply that down through 3x squared times x. 3x cubed. 3x squared times positive 2. Positive 6x squared. Do not forget the most important step. Change the sign, change the sign. Now we're going to add straight down and see what's left under our house so that we can start all over. This becomes a 0. Careful here. Negative x squared minus 6x squared. Minus 7x squared. We still have this minus 7x. We still have plus 6. And now we're back to our first step. We go off to the side and we focus on the leading term. So we're taking negative 7x squared divided by x, which is negative 7x, correct? That's what goes up top, minus 7x. Now we're going to take and multiply that back down. Negative 7x times positive x, negative 7x squared, correct? Okay. Then negative 7x times positive 2. Negative 14x's. We won't forget the most very important step, which is change the sign, change the sign. Now we're going to add straight down. Those become 0. Oh, what does that become? 7x, and then we have plus 6. Now we're back to the first step. We go off to the side, do our bulletin just to show our work. So we're doing 7x divided by x, which is 7. That's positive 7. So we have plus 7. So now we're going to take and multiply that 7 back down through. Positive 7 times x. 7x. Positive 7 times positive 2. Positive 14. Most important sign. Change it, change it. We add straight down. 0 and then negative 8. So now look, does negative 8 divide by x? No, so we can't do that. So that's our remainder. We have a remainder of negative 8. So this did not divide evenly. We could still divide it though, just like we could divide that 9 by 2. So our remainder is negative 8. So this is how we write it. So we're going to do, just like in that first example here, that easy example, we take this and we're going to add our remainder. So what we're going to do is we're going to say, okay, right here. So we're down here, if I can get back down there. So what we're going to do is we have this polynomial, and then we have plus our remainder. So plus -8, but it's not just plus -8. It's -8 over x plus 2. That's what was left when we divided x plus 2. So you got to write your remainder over what you divided by. That's just how you write it. Now, plus a negative, isn't that just subtraction? So I'm going to actually say just minus 8 over x plus 2. So our final answer would be just this part right here. Ding, 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 ding. So this must not have been a perfect factor, correct? Okay, that's what we need to know. Now, I didn't say this to you, and this is what's really important. Everybody listen to this is the most important part. Okay, this is why we're going to use this in the future. So I want you to see this. Didn't we take and divide a polynomial down from a cubic, and then we divided it by a linear? So didn't we get something quadratic left over? And then we would know how to solve a quadratic. Does that make sense, everybody? So we're not applying this today. We'll apply it a different day, but I just want you to see where this is going and how this is possibly going to help us. Okay, are you guys ready to try one, or do you want me to do one more with you and then let you try a few? You want to try one? So let's try number 30. We're going to learn another method in just a second. Everybody, so let's go through this one really quickly. So on our outside of our house, we have our 3x plus 4. Inside our house, you know how it works. So if you have made an error, try to see where. So we focus on our leading terms. So we have 6x cubed divided by 3x, we get 2x squared, right? That goes back up top, 2x squared. Then we multiply it back down. So that'll be 6x cubed and then plus 8x squared, correct? Then I have to remember to change the sign. Now we add straight down. 0, negative 6x squared. We still have a negative 11x, and then a 12. And the process starts over. So we have our negative 6x squared divided by 3x, which is negative 3x, correct? Did I make a mistake anywhere? Is everybody that got it right doing good? So I'm going to subtract 3x. Now I multiply it back down. Where's negative 2x? Okay, I felt like something felt weird about that. So this is minus 2x, correct? 6 divided by 3, minus 2x. Negative 2x times 3 is negative 6x squared. Negative 2x times 4 is negative 8x. The most important thing is to change the sign. We add straight down. 0. Right, so negative 3x plus 12, right? The process starts over. Negative 3x divided by x is negative 3. That goes back up top. And then same thing. We'll have negative 3x minus 12. Then we, wait a minute. What equals negative 1? Where did I mess up? I'm going too fast. This is a 3x right here. This is negative 1. I'm going too fast. Negative 1. Well, I am, because that's why I'm making these errors. Negative 1. Negative 1 times 3x is negative 3x, correct? Negative 1 times positive 4 is negative 4. There we go. Now we change the sign. We add straight down. We get 0 plus 16. So our remainder was 16. So here's our answer with a remainder of positive 16. So plus 16 over 3x plus 4. Okay. Questions? Are you ready to practice some more? Okay, do 1 through 6. Ready, set, go. Synthetic division. Synthetic division is just another method to divide polynomials. However, you will only ever use synthetic division if, listen, if you have a linear, if you're dividing by a linear factor, so that means degree 1, correct? That has a leading coefficient of 1. Do you see how this is a 1 and a 1? That's the only time we'll use synthetic division. So do you see why we would learn long division? Because we would not use it with this one. Do you see it? Okay, so that's why we learn long division. Long division works no matter what. If the leading coefficient is 3, that's fine. If the leading coefficient is 1, that's fine. However, synthetic division only works or only is good to use if your leading coefficient is 1 and it's linear. Okay, so it's a different process, but it's way quicker than long division. Here we go. This is what you do. You do not use the factor. This is the factor. So x minus 5, you're going to actually use the 0, the solution. So we would set it equal to 0 and solve. So isn't that positive 5? Okay, we're going to use positive 5. That's one thing you have to remember. So we're using the opposite of that sign, but that's why. It's because we're using the actual solution. Does everybody understand? Yeah. Okay, now you're going to draw a house that's upside down. You're going to leave yourself some room. Draw your house about like this. Now what you're going to do is you're going to put in your coefficients. And coefficients are the number in front of the variable. So do you see how there's a 1 in front of x cubed? So we put a 1, then there's a negative 8 in front of x squared. We've got to put this in order. X cubed, x squared, then x, so then 17, and then negative 10. Now, one other thing to note, you have to have every single coefficient listed that's in order. So do you see how we have degree 3, 2, 1, then constant? If we were missing negative 8x squared, let's say we had x cubed plus 17x minus 10. We'd put a 1, a 0, because there's no x squared, and a 17 and a negative 10. That's one of the most forgotten things to do, and then you miss it. Does everybody see what I'm saying? Okay, now we're going to drop this one down always. Exactly, just drop it straight down. So drop that down, whatever that is goes right here. Now we multiply up. We always multiply up. So 1 times 5. 5. And so we put 5 right here, and we always add straight down. So we always add straight down. That's negative 3, correct? Then we multiply up. We're always multiplying up. Negative 3 times 5. Negative 15, and then we always add straight down. Okay? 2 times 5, 10, and then we add straight down. 0. Now here's what's important to know. So you're like, what is that? I'm going to tell you. Didn't we go from a degree 3 and we divided by degree 1? Wouldn't that be degree 2? We took it from a cubic polynomial, we divided it down to a quadratic. So that's degree 2. So this is x squared, this is x, this is constant. That's in order, right? I'm just going backwards, and this is our remainder. So our polynomial was, these were the coefficients. 1x squared, which is x squared, minus 3x, plus, because that's positive 2, plus 2. And it had no remainder. So we are done. We divided the polynomial using synthetic division. Wasn't that way quicker than long division? Especially when you get good at it. Now we would write this the same as we did our other polynomials. If we would have had a remainder, we would have done plus 2 over x minus 5. You know what I mean? So let's do another one. It's just learning a process. This is the one we're going to use most of the time from here on out. Okay, number 12, let's do it. So we have x plus 2. We've got to remember with synthetic division, we use the actual 0. So we're going to subtract 2. So we're going to be using negative 2. Then we draw our little house thing. You're putting the coefficients and making sure you're not missing any. 3, 2, 1, not missing any. So we have a 1, a 5, a negative 1, and a negative 9. Does everybody see where I got those? Here's what you have to remember. This one just always drops straight down. You multiply up. 1 times negative 2 is negative 2, correct? Then we always add straight down. 3. 3 times negative 2, negative 6. We add straight down. Negative 7. Negative 7 times negative 2 is 14. We add straight down and get, it's 5, right? Now we have to ask ourselves, what are we looking at here? We went from degree 3, we divided by degree 1, so that's degree 2. So this is going to become quadratic. 1x squared plus 3x minus 7, and then our remainder was 5. So we would say, and it's positive 5, so plus 5 over x plus 2. That was way quicker than long division. So I'm going to ask you a question. Was x plus 2 a factor of this polynomial? No, right? Because our remainder wasn't 0. If our remainder is 0, then that's a perfect factor, divided evenly. Does that make sense, everybody? Okay, that's where we're going to use that in the future. Okay, so do you want me to do problem number 31 with you, or do you want to just start practicing, or what do you want? You're good to start practicing? You sure? Okay. So, look, one thing I do want you to look at, though. Let's just at least set this one up. We have a 4, a 2, and then a negative 10. You see that we would use synthetic division for this one? Everybody look, because this would be where you would miss it if we don't at least see 1. And I won't go through the whole thing. Are we going to be using positive 2? Okay, now we have to do 4, 3. Do you see we're missing 3? So we would put a 1, then a 0, and a negative 3. Are we missing x too? We'd have to put in a 0 and then negative 10. And then we'd just go through the process. Does everybody understand that, though? Really important to remember. Yeah. We're missing x cubed, we're missing x, so the coefficients were technically 0. You have to have all of the coefficients leading down. Okay, do 11 through 20, synthetic division. Don't say, I just like long division, I'm not going to learn synthetic. You have to learn synthetic. And on an ACT, if you were given a problem like that, if you were given a problem like this, you would want to do synthetic division because it's way quicker, and time is money on the ACT. And we're going to use synthetic most of the time.